Welcome to our deep dive. We'll be exploring the fascinating world of flow control in Rust.
It's a core concept in programming.
Yeah, and Rust approaches it in a really elegant and efficient way.
Yeah,
You
definitely.
can kind of think of flow control as like the roadmap of your program.
Mm-hmm.
Like it dictates which instructions are executed and when.
Right.
Kind of like those old choose your own adventure books
Yeah.
where your decisions shape the story's path.
That's a really good analogy, actually. It's all about like decision points and how those choices determine the flow of execution.
Exactly. Now, Rust can sometimes seem a bit intimidating to newcomers,
Yeah.
but bear with me on this deep dive because we'll be revealing how Rust makes flow control surprisingly intuitive
Hmm.
and really powerful.
Definitely.
And we're going to start with a seemingly simple concept, the if statement.
It might seem simple at first glance,
Right.
but Rust's if statement has a kind of a fascinating twist.
Okay.
It's not just about executing a block of code based on a condition.
Yeah.
In Rust, if statements are actually expressions,
Oh.
meaning they can return values.
Wait, so an if statement itself can produce a result?
Exactly.
I'm intrigued.
Think of this line of code. Let value if condition expression 1, expression 2.
Oh.
So depending on that condition,
Yeah.
that value will be assigned the result of either expression 1 or expression 2.
So it's like the if statement itself becomes this mini factory,
Mm-hmm.
churning out a result based on the input condition.
That's a great way to visualize it.
Yeah.
This characteristic is actually borrowed from functional programming,
Okay.
and it just allows for incredibly concise and expressive code.
Yeah, I can already see how this could lead to much cleaner code,
Right.
more readable
Absolutely.
compared to other languages.
Yeah, you often have to use temporary variables
Right.
or multiple lines to achieve the same result.
Okay, interesting.
And that's just the beginning.
Okay.
Rust's design choices often have these sort of elegant ripple effects
Right.
throughout the language.
Cool. Okay, let's move on to loops.
Okay.
I understand that Rust has three main types of loops. Loop, while, and
You got.
can you give us like a quick rundown of their differences?
Yeah, so think of them as like specialized tools in a programmer's toolbox.
Okay.
Each loop serves a specific purpose
Right.
and excels in certain scenarios.
Um,
Loop is like the most basic form.
okay.
It's an infinite loop
Uh-huh.
that keeps running until it's explicitly instructed to stop using a break statement.
Okay.
So imagine a robot just tirelessly performing a task
Yeah.
until you hit the off switch.
So it's a continuous cycle until we intervene with a break command.
Exactly.
And what's interesting is this break can optionally return a value
You got it.
from the loop.
Yeah.
So it adds another layer of flexibility.
Mm.
It's like the robot handing you a report after completing its work.
Exactly. Now, while Bribberga is a bit more targeted,
Okay.
it keeps looping as long as a given condition holds true.
Okay.
So it's like telling the program, keep checking for new emails
Uh-huh.
until you find one from a specific sender.
That makes sense.
Yeah.
That's
Yeah.
ideal for scenarios where the repetition depends on some dynamic condition.
Right.
That might change over time.
Absolutely.
Gotcha.
And finally, we have the for loop,
Okay.
which is perfect for iterating over a sequence of elements,
Okay.
like items in a list or characters in a string.
Mm-hmm.
Rust's for loop is exceptionally efficient thanks to its implementation using iterators.
Okay.
It's like a finely tuned machine,
Uh-huh.
smoothly processing each item in a collection
Okay.
without any unnecessary overhead.
So we've got the workhorse loop,
Mm-hmm.
the conditional while,
Right.
and the efficient for loop for collections,
Exactly.
each with its own strengths.
Yeah.
Now, you mentioned something earlier about break statements in loops,
Yes.
particularly with nested loops,
Right.
which can get pretty complex.
They can. And how does Rust handle that?
So that's where labeled breaks come into play.
Okay.
They allow for incredibly precise control.
When dealing with these nested loops within loops,
Right.
imagine you have a multi-level security system.
Yeah.
And you need to be able to exit from like a specific security checkpoint,
Right.
even if you're deep inside the facility.
Okay. So labeled breaks are like having a specific escape route
Exactly.
from a complex, multi-layered system.
Exactly.
Can you give us an example of what that looks like in code?
Certainly. Imagine you have a program that's analyzing a large data set
Okay.
for specific patterns.
Yeah.
You might have nested loops to iterate through rows and columns.
Okay.
A labeled break would let you exit both of those loops instantly if you encounter a critical error,
Okay.
preventing further processing
Right.
and potential data corruption.
So it's like hitting an emergency stop button
Yes.
that halts the entire operation.
Exactly.
That's a great example. It illustrates how Rust allows you to handle those intricate situations with clarity and control.
Yes.
Now, I'm curious about something. Doesn't all this emphasis on control and safety come at a performance cost?
That's a great question.
Wouldn't all these checks and safeguards slow things down?
That comes up a lot with Rust, actually.
Yeah.
But what's remarkable is that Rust manages to achieve both safety and performance.
Right.
Largely due to its use of zero-cost abstractions.
Zero-cost abstractions. That sounds almost like magic.
It might seem that way, but it's really just a clever combination of compiler design and language features.
Okay.
So essentially, zero-cost abstractions mean that you get all the benefits of this clear and safe code without paying a performance penalty at runtime.
Okay, so the compiler's doing some heavy lifting behind the scenes to ensure that our code runs efficiently.
Right.
Even with all these safeguards in place.
Precisely. The compiler actually analyzes your code and optimizes these abstractions, often generating the same efficient machine code that you might write manually.
Right.
But without the risk and complexity, it's like having a super efficient assistant.
Who's translating your high-level instructions into this optimized machine language without sacrificing any safety?
That makes a lot of sense. So Rust is providing these powerful control flow mechanisms without sacrificing performance. It's like getting the best of both worlds.
You got it.
But what about more complex decision-making beyond simple conditions?
Yeah.
Does Rust offer any tools for that?
It does. That's where pattern matching comes in.
Okay.
A truly powerful feature that takes flow control in Rust to a whole new level.
Okay.
But before we delve into that, let's just take a moment to solidify our understanding of these core concepts.
Sounds good.
That we've discussed so far.
Yeah, it feels like we've already uncovered some surprising aspects of flow control in Rust.
We have.
And I'm eager to see where this deep dive takes us next.
Me too. Welcome back. I'm really eager to dive into this concept of pattern matching.
Okay.
Which, as I said, takes flow control to like a whole new level of expressiveness and power. From what we've covered so far, it sounds like pattern matching goes beyond just those simple conditional checks.
Absolutely.
Is that right?
Yeah, in a lot of languages, you're kind of limited to just comparing values for equality.
Okay.
Like checking if a variable holds a specific number or something.
Right.
But Rust's pattern matching lets you actually like dissect data based on its structure and type.
Okay.
So it allows for some really sophisticated decision making.
So it's not just about checking if something is equal.
Right.
It's more about like understanding the very nature of the data itself.
Yeah.
And then making decisions based on its inherent form.
That's a great way to put it.
Yeah.
So imagine you're processing incoming data.
Okay.
That could be a variety of things.
Right.
Numbers, text, or even complex objects with multiple properties.
Right.
Pattern matching lets you write code that can gracefully handle each of those possibilities with like remarkable clarity.
So I'm starting to see how this is different from just a series of nested if statements. It feels like a more structured and elegant way to handle those various data scenarios.
Precisely.
Yeah.
And that elegance is like more than just aesthetic.
Right.
It leads to code that is way easier to read, to reason about, and to maintain.
Right.
Which is super crucial for any serious project.
Okay, so walk me through how this actually works in practice.
Okay.
What does a pattern match look like in Rust?
So it uses the match keyword.
Okay.
Think of it like a multifaceted switchboard that's analyzing a piece of data and then directing the flow of execution based on its characteristics.
Okay.
So you provide it with a series of patterns.
Okay.
And each pattern has some corresponding code that will execute if that pattern matches the input.
So instead of just checking if something is true or false, you're checking if it fits a specific pattern.
Exactly.
Which could be quite complex.
It can be.
Yeah.
Let's say you have a variable that could hold different types of geometric shapes.
Okay.
Like a circle, a square, or a triangle. But with pattern matching, you could write code that responds differently.
Okay.
Based on the actual shape contained in that variable.
It's like the code can intelligently identify the shape and then execute the appropriate instructions for that specific type.
Exactly.
That's incredible.
It is. Yeah. And it gets even more interesting.
Okay.
Pattern matching isn't just limited to like simple types, like numbers or strings. You can match against like complex data structures too.
Like what?
Like arrays, tuples, and even custom data types.
Wait, so I could write code that responds differently?
Yes.
Based on the specific arrangement of elements within an array?
Absolutely.
Or the contents of a custom structure?
Yes. Imagine you have a custom data type that represents a user profile with fields like username, age, and location. Pattern matching would let you write code that branches based on very specific conditions, like whether the user is over a certain age or if their location matches a particular region.
Wow. This is starting to feel like a superpower.
Yeah.
It's like having this X-ray vision into these data structures.
Yeah.
That allows me to make decisions based on their internal composition.
That's a great analogy.
Yeah.
And what makes it even more powerful is the flexibility that Rust offers. So you can use wildcards to match any value. Or you can specify very precise conditions that have to be met. So it gives you this fine-grained control over how your code responds to these different data scenarios.
It's like having this specialized set of tools for dissecting data and then responding accordingly.
Exactly.
This is a lot to take in, but I'm starting to see how pattern matching really elevates flow control to a whole new level.
Which does.
Yeah, but how does this all work under the hood?
So the magic is really in the combination of Rust's syntax and its intelligent compiler. So when you write a pattern match expression, the compiler analyzes it.
To understand all the possible scenarios that you've outlined. And then it generates code that can efficiently check the input data against these patterns.
So the compiler is like a detective. Scrutinizing the code, figuring out how to match data against the patterns I've defined.
It is.
It's almost like it's anticipating all the possibilities and preparing for them.
Exactly. And during this analysis phase, the compiler also performs a really essential task. It checks for completeness. It makes sure you've covered every single possible scenario that can happen. So it prevents these potential errors where your code might encounter some unexpected data and just not know what to do. It's like having a second pair of eyes. Scrutinizing your code for any potential oversights.
That's incredibly helpful, especially when dealing with complex data structures or situations where you need to account for a wide range of possibilities.
It's like the language itself is helping me write more robust and error-free code.
That's a core principle behind Rust's design. Now, I know we've covered a lot conceptually. Would you like to see some more concrete examples of how pattern matching is actually used?
Absolutely.
In like real world scenarios.
I think seeing how this translates into those practical applications would really help me solidify my understanding.
So pattern matching really shines in areas like error handling and resource management. So let's start with error handling. Unlike some languages that rely on exceptions, which can be really unpredictable and really disrupt the flow of a program.
They can.
Rust uses a special type called result.
I've heard of result. It's like baking the potential for errors into the data itself.
Exactly. Result represents the possibility of both success and failure. And pattern matching works beautifully with it. So you can use match to handle both the OK variant, which means success, and the error variant, which obviously means failure, with remarkable clarity.
So instead of this like tangle of if statements, checking for null values or exceptions, you just have this clear and structured way of dealing with both success and failure scenarios. Using pattern matching.
Precisely. This leads to much more robust code. That's easier to understand. You can anticipate and handle those various outcomes without disrupting the flow of your program at all.
It's like having this built-in contingency plan for every operation. I like that.
So it feels like this approach really encourages proactive error handling rather than just like reacting to those problems after they come up.
I like that a lot better. What about resource management? How does pattern matching come into play there?
So resource management, as you know, is all about carefully handling resources like files, network connections, or memory. Rust's ownership system is excellent at this, but pattern matching adds another layer of finesse.
I'm all ears.
All right, so a common pattern is using match to handle the different states of resource. For instance, a file could be in an open state, a closed state, or an error state. Pattern matching lets you gracefully handle each of those states. So it ensures that the resources are properly released and that any errors are dealt with appropriately.
So it's like having a built-in state machine.
You got it.
for managing those resources.
Yes, yes.
Ensuring that they are handled correctly in every scenario.
It is.
This is really cool.
So this pattern is invaluable for writing reliable code.
Okay.
Especially when you're managing these complex resources or operations.
Yeah, this is all starting to click for me now. It feels like pattern matching is like woven into the fabric of Rust.
It is.
It's impacting how we handle errors, how we manage resources, and even how we make complex decisions based on data.
Yeah.
It's not just about control flow.
Right.
It's about writing cleaner, safer, more expressive code.
That's an excellent observation.
Yeah.
Pattern matching is fundamental to Rust's philosophy of empowering developers to write code that is both powerful and reliable.
I'm really impressed with how Rust handles this flow control.
Yeah.
Seems like a real paradigm shift from what I'm used to.
It is.
In other languages.
It's a different way of thinking for sure.
Yeah.
But once you grasp its principles, it can really change the way you approach programming.
I can see that.
It's about embracing clarity, safety, and expressiveness.
This has been an incredible deep dive so far.
Yeah, it has.
We've explored the foundational flow control, delved into those labeled breaks, and uncovered this amazing power of pattern matching.
We have.
I feel like we've barely scratched the surface.
There's always more to learn.
Yeah.
But for now, let's just take a short break.
Okay.
And then we'll wrap things up with some final thoughts.
Sounds good.
And maybe a question to ponder as you continue your Rust journey.
Okay. Welcome back to our deep dive into Rust flow control.
We've covered a lot of ground.
Yeah. From those basic loops
to
the intricacies of pattern matching.
Absolutely.
It's really clear that Rust takes this very deliberate approach to how our code actually executes.
It's not just about getting the job done, It's about doing it safely, efficiently, and in a way that makes sense to both the developer and the compiler.
Exactly. Speaking of the compiler, we've talked a lot about how it optimizes our code and ensures safety, but I'm curious, are there any downsides to this approach? Does this, constant analysis and optimization ever add overhead or complexity to the process?
That's a great question.
Yeah.
And it's one that a lot of developers initially have when they first encounter Rust.
Okay.
So it's true that the compiler is doing a lot of work behind the scenes.
Right.
But it's remarkably efficient.
Okay.
In most cases, the compilation time is well worth the benefits that you get. Safety and performance at runtime.
So the trade-off is we have a slightly longer compilation process. But in return, we get code that is much more likely to be correct. And perform it right from the start.
Exactly.
It's like investing a bit more time up front to avoid those costly bugs and performance tuning sessions.
Precisely. And, there are tools and techniques that developers use to manage those compilation times, especially in larger projects.
Right.
But I think the key takeaway here is that Rust's approach really does pay off in the long run.
Right.
Especially when you're building complex and critical systems.
Makes sense.
It's like taking the time to build a really solid foundation.
Yeah.
Rather than just rushing through it.
Right.
And risking instability down the line.
Yeah. I like that analogy.
Yeah.
No, I want to circle back to something you mentioned earlier about functional programming. We talk about how Rust's if statements are expressions that can return values.
Yeah.
Which is a concept that's borrowed from functional programming.
It is.
I'm kind of curious to explore this connection a bit further. How does this functional influence manifest itself in Rust's flow control? And what are the implications of that?
That's a fascinating aspect of Rust.
Yeah.
The functional influence goes way beyond just if statements. It kind of permeates a lot of aspects of flow control, encouraging a style of programming that emphasizes immutability, pure functions, and the avoidance of side effects.
I'm familiar with those terms in a general sense.
Yeah.
But can you elaborate on how they apply specifically to flow control in Rust?
Certainly. So immutability, for instance, means that once you assign a value to a variable, it can't be changed. This might seem a little restrictive at first. But it eliminates a whole class of potential errors that can arise from mutable state.
So it's like creating a system where the data is much more predictable.
Exactly.
And less prone to these unexpected changes.
Right.
Which makes it much easier to reason about the flow of execution.
Precisely. And pure functions
Yeah.
are essentially functions that always produce the same output
Okay.
for a given input.
Okay.
And they have no side effects,
Okay.
meaning they don't modify
Right.
any sort of external state.
So very predictable.
They are.
And easy to test.
And easy to test, exactly.
Which contributes to the overall reliability of the code.
Of the code, yes.
It's like building with Lego blocks.
Yeah.
Each block has this like defined behavior.
Yes.
And when you combine them,
yeah,
you get these predictable
yes.
and consistent results.
That's a great analogy.
Yeah.
And this functional approach also encourages a style of programming
Yay.
where you compose smaller, well-defined functions
Right.
to achieve those more complex tasks.
Okay.
It's like building a complex machine out of these smaller, well-tested components.
Right. So this functional influence in Rust
yeah.
really promotes a more structured,
It does.
predictable,
yes.
and ultimately more reliable approach to flow control.
Exactly.
It's really fascinating to see how these concepts from these different programming paradigms
yeah.
blend together in Rust.
It's one of the things that makes Rust so unique,
Yeah.
compelling.
Yeah.
You know, it takes the best ideas from these various paradigms
Yeah.
and combines them in a way that feels both familiar
Right.
and really innovative.
This has been a really incredible deep dive
It has.
into the world of flow control in Rust.
Yeah, we've covered a lot.
Yeah, we've explored the basic building blocks, uncovered those unique features,
Yeah.
and we've even delved into the philosophical underpinnings
A little bit.
of how Rust approaches code execution.
We have.
And we've only just scratched the surface.
We have.
There's still so much more to learn,
Absolutely.
like those advanced pattern matching techniques
yeah.
and the nuances of asynchronous programming.
That's a whole other world.
But I hope this deep dive has given you a really solid understanding
I think so.
of the core principles and the power of Rust's flow control mechanisms.
Definitely.
It's clear that Rust encourages this very deliberate and thoughtful approach to programming,
Yeah, it does.
one that prioritizes safety, clarity,
Yeah,
and efficiency.
absolutely.
And as we wrap up this deep dive, I
Wow.
want to leave our listeners with a challenge.
Sure.
As you continue on your Rust journey, think about how these flow control mechanisms can help empower you
Yeah,
to write better code,
Yeah.
more reliable code,
absolutely.
and ultimately more elegant code.
I love it.
Embrace the concepts we've talked about.
Yeah.
Experiment. And don't be afraid to really see what you can build
Absolutely.
with Rust.
And remember, the Rust community is incredibly welcoming and helpful.
That's a really good point.
There are tons of resources available online,
Right.
documentation, tutorials, forums.
Yeah. It's always more enjoyable and rewarding
Absolutely.
when you have that supportive community behind you.
You got it.
So dive in,
Yeah.
explore, and don't be afraid to ask for help.
Exactly.
That's really important.
Yeah.
Well, we've reached the end of our deep dive.
We have.
Thank you so much for joining us
It's been a pleasure.
on this exploration of flow control and Rust.
I hope you enjoyed it.
We hope you've enjoyed the journey.
Until next time.
Keep exploring, keep learning.
And keep building amazing things.
Happy coding.